T-minus 5, 4, 3, 2, 1. Booster ignition and liftoff of Discovery.
What is thermodynamics? Well, thermodynamics is a branch of engineering that deals with the energy and the heat transfers of a system. It is an essential subject for understanding how machines, devices, nature, and the world around us work. It includes absolutely everything, from car engines to refrigerators to power plants. It affects the plane flying through uneven airflow caused by temperature fluctuations in the atmosphere. Even the variability of an airplane that moves is thanks to the engines that produce work from the fuel by using the heat liberated to increase the temperature of the air drawn to the engines. This air is then used to produce work by expanding and pushing against the blades of the turbine, which in turn causes the engine to rotate. It also plays a role in the efficiency of the very vehicle you drive, since a combustion engine is essentially a device that turns controlled explosions into rotational movement thanks to a series of piston cylinder assemblies. Something as simple as the air conditioner of your house or car works thanks to a well-known thermodynamic cycle, the refrigeration cycle, which is the process by which heat is transferred from a low temperature location to a high temperature location. Batteries, small electronics, nuclear plants, a ball bouncing. These are things with characteristics and that exhibit behaviors that can be better understood if we dig deeper into the thermodynamic laws. Which are the thermodynamics laws? We have three. The first law of thermodynamics, the law of energy conservation, states that the energy cannot be created nor destroyed, only converted from one form to another. This means that the total amount of energy in a closed system, which is defined as a system in which only the exchange of energy is allowed, but the exchange of matter is not allowed, remains constant, even as the energy is transferred from one object to another or converted from one form to another. The second law of thermodynamics, the law of entropy. It is all about the concept of entropy, which can be defined as the measure of disorder in a system. This law states that the entropy of a closed system will always increase over time. In other words, energy will always flow from hotter objects to cooler ones, and the system will eventually reach a state of equilibrium where all the energy is evenly distributed. The third law of thermodynamics. It's based on the idea that it is impossible to reach absolute zero, or the temperature at which all matter has no energy. It states that it becomes increasingly difficult to extract work from a system as it approaches to absolute zero, because there is less and less energy available for the system to use. This is due to the fact that the atoms and molecules in the system are moving more slowly and are less able to interact or collide with each other as the temperature decreases. In simple words, if there are less molecules in a system, there are less collisions that would help to quote-unquote push energy out. So what can we learn from all of this? Well, thermodynamics is a key concept in many different fields, including mechanical, electrical, and chemical engineering. It's an important branch of engineering that helps us understand the transfer and conversion of energy in a system. It is used to improve design and optimize the performance of a wide range of devices and systems, and it's essential for understanding how the world around us works. Thanks for tuning in. I will continue to upload more educational content related to science and engineering. If that's something you like, make sure to subscribe and don't forget to leave a like. Take care.